Hey everybody, so we're going to be talking about making angles using secants, chords, and tangents that are going to be intersecting on a circle. So the way that this is going to happen is there are going to be three different types of intersections. You're going to have it on the circle, you're going to have it inside the circle, and you're going to have it outside the circle. The first kind that we're going to work with is on the circle. Now, if it's on the circle, then each angle formed is going to be equal to half the measure of its intercepted arc. Pretty much, I want you to treat this like it's an inscribed angle, because that's the exact same formula. Pretty much, if you've got the measure of angle 1, then it's going to be equal to half of the arc of AB, half of that measure. Same thing happens with angle 2, where it's going to be the half of measure of the arc BCA, even if it's a major arc. It doesn't matter if it's a major or a minor. It's still going to be half of that arc. So right here. So let's go ahead and do an example. The first one that we're going to do is we're going to find the measure of arc QS. All right. Well, in order for us to find the measure of arc QS, we either need the measure of arc QTS, or we need the measure of angle RQS. Now, technically, you could say that we don't know either of them, but you can figure out the measure of angle RQS. And that's because line PR is 180 degrees. That means this right here is going to be 180 minus 128. Which is going to get us to equal 52 degrees. So let's write it out. We know that this angle right here is going to be half the measure of its arc. So the measure of angle RQS is equal to half the measure of arc QS. We know that the measure of angle RQS is 52 degrees. And that is half of the measure of arc QS, meaning if we double it on both sides, we're going to get that it's 104 degrees for the measure of arc QS. And that's really how easy it is, just like we've been doing with inscribed angles. So similar to this one, we're having to find the measure of angle JLK. Well, we're going to have to work backwards a little bit, and you can do it two different ways. First, you can figure out that this entire arc right here is 298 degrees. Okay, let me put that back in because that's what we're looking for. So you can either figure that out and then figure out the measure of arc JL and go halfway backwards. Or if you want to work harder, what you can do is find the measure of angle JLM and then subtract it from 180 to find this angle right here. I like to work smarter, not harder. So I know that the measure of arc JL is going to equal 360 minus that 298, meaning it's going to equal 62 degrees. So let's set up our equation. We know that measure of that angle, JLK, is equal to half the measure of the arc JL, that minor arc. Meaning, if I plug everything in, half of 62 is going to get me the measure of angle JLK. Which means that's just going to be 31 degrees. Again, this is super easy. It's like an inscribed angle. What gets confusing is when we're working with inside the circle and outside the circle. Now check this out. We've got this little kiddo here with an umbrella. And I want you to think about when it's raining, and especially with the storms happening nowadays, you know, this will be helpful for you. Think about it with all the rain that we get in April. So I want you to think about inside the circle as you are inside of the umbrella. When you are inside of an umbrella, whether it's raining or whether it's sunny, that is a positive thing. You are happy that you are under the umbrella. Okay? Which means you're going to be adding. And you might ask, hey, what am I adding? Well, I want you to think about it as a big arc and a little arc. I'm going to call it big little. Your big little, you're going to be adding when you are inside the circle. Which means if you're outside the circle and it's raining or it's sunny, you're going to be kind of upset. It's a negative thing to happen to you. So you're going to subtract the big and the little when you're under the umbrella. Or sorry, not under the umbrella. There we go. Because you are outside of the umbrella. So I want you to think about this little guy. Okay? Think about it. Are you under the umbrella or are you outside the umbrella? So it doesn't matter if it's two secants or if it's two chords that are intersecting. If they are intersecting inside a circle, the angle formed is going to be equal to half the sum, meaning we're adding, the measures of the intercepted arcs. So the measure of angle 1 right here, you're going to add up the measure of arc AD plus the measure of arc BC. And for this case, it's not really going to matter just because, well, you're adding, so the order is not going to matter as much. But here's what's going to happen here. When you're subtracting, that's when it's going to make a difference. So let's find the measure of angle 2, your big plus your little. So remember, it's your angle is going to equal half.
Teachers, pardon this interruption.
Sorry.
A reminder that all 7th grade biology classes are meeting in the cafeteria. You've got a class in the portable, go to the cafeteria.
So half of the big arc plus half of the little arc, okay, is going to equal the measure of that angle. So I'm going to do half of the measure of arc AB plus the measure of arc CD. Again, we're adding them up. That's what sum means. So an example of this would be this one. Okay, so the measure, we're trying to find the measure of arc AD right here. We've been given this angle, and we've been given this arc. So what would really help me is to write it in this setup right here. Our angle, so angle BEC, is equal to half of my big arc, which is arc BC, plus the measure of arc AD, which is my little arc, the one that I'm actually looking for. So the measure of angle BEC is 93 degrees, and that is going to be half of 161 plus the measure of arc AD. All right, so one way I'm going to do it is I'm just going to double it so I can get rid of that half and get rid of that fraction. So I know that 186 is equal to 161 plus whatever the measure of arc AD is. Then to solve, you're going to subtract 161 from both sides, and you find that the measure of arc AD is 25 degrees. And yes, it's really that easy. So now let's do this one. We've got an equation, and we're going to solve for x. So again, your angle, the measure of your angle, is equal to half of the sum of your big arc plus your little arc. It's your big plus your little. So we have 5x minus 7 is equal to 1/2 times 119 plus 27. Because you've got your big arc and your little arc here with this angle. Now, you can do it two different ways. You can multiply both sides by 2 and get rid of that half. Or you can apply that half to the 119 plus 27. Honestly, you do whichever way works best for you. I'm going to show you both ways. This is if I distributed that 2. And I'm sorry, multiplied it by that 2. So I get 10x minus 14 is going to equal 146. Move the 14 over, and I get that x is going to equal 16. Now, had you multiplied that 1/2 to begin with, so we did 119 plus 27 This is 146 right here. 5x minus 7 is going to equal half of that 146. Half of 146 is going to be 73. Add the 7 over, and it gets you 80. And x is still equal to 16. So it doesn't matter which way you do it, whatever helps your brain. All right, this next one is going to be outside this circle. So remember, you are outside of the umbrella when it's pouring down rain or when it's super sunny. So what's going to end up happening is that if they intersect on the exterior of a circle, then the measure of that angle is going to equal to half the difference of the intercepted angles. I'm sorry, the arcs, which means, remember, difference means that you're going to subtract. So whether it's two secants, a secant and a tangent, or two tangents, it's still going to be the same thing. The measure of your angle is going to equal half of the big minus your little. So right here on your two secants, you've got the measure of angle A is going to equal half of the measure of arc CE minus the measure of arc BD. Same thing happens with your secant and your tangent. It's between your 2 points that it's touching. So BD and BC, it's going to be half of adding those. Oh no. Again, I'm sorry, subtracting those. I think I said adding. And we're going to do big minus my little. And it is going to be the measure, but we're kind of running out of room. So if you just write the arc and its name, that is totally fine. Same thing here with the two tangent. It's going to be this major arc minus your minor arc. So it's going to be half of arc BDC minus half of the measure of arc BC. If you want to put that M, or if you have the room, then go ahead and do it. All right, so remember, it's going to be the angle is going to equal half of the big minus little. In this one, we're looking for the measure of angle EFG. Pretty much, we're just looking for that measure of that angle. And the measure of that angle, EFG, is going to equal half of this arc right here, your big arc, so arc DH, minus the measure of your little arc right here, arc EG. Well, let's plug in what we have. The angle of EFG is going to equal half of 121 minus 39. 121 minus 39 is equal to 82, and half of 82 is 41 degrees. So the measure of angle EFG is equal to 41 degrees. Remember, it's half of your big minus your little, because we are outside, both of them are intersecting outside of the circle. You're going to set it up the same way here when we're solving for x. It's going to be half of the big minus my little to find the measure of my angle. So its angle is equal to 1/2 times big minus little. So you've got 2x plus 7 is equal to half of 78 minus 32. And this one's pretty easy, and you can go ahead and solve for x. And you should get that x is equal to 8. All right, I would recommend you simplified your parentheses, distribute that 1/2, and then solve for x. Thanks for watching.